Monday, right? All right. So we are moving on now to classes. Classes are one of the foundational principles of object-oriented programming. This is what we're talking about. This idea. So, Cycle 1, Computer Science 2 is starting programming, understanding all the basics, then moving into object-oriented programming principles, and then looking at interesting ways that you can store data in memory. So we've come a long way, which is awesome. Looking at some of these specific goals here. Didn't spend a lot of time with use case and activity developments. We can get through there's a lab, which is a great different ways of designing programs. No problem. Start getting into that with class. We now have the ability to do this a little differently. Our store project, we all use the same dictionary of dictionaries or dictionary of lists, or some people have two different dictionaries, and there are lots of different ways we can solve that same problem. They all work, which I finally got graded. Thank you for bearing with me here. Next up is the second project on the list, but those first ones are in. Making test cases. This is more important now that we start talking about classes. We've always kind of been, does our code work? Writing tests. So this idea of making test cases we'll get into. Taking a problem and breaking it down into smaller problems. This is our functional decomposition, my favorite technical term ever. Throw that out at your Thanksgiving Halloween party, and just watch people like these faces do. Nerd. No one's surprised at me anymore. Maybe they don't know about you, though. These integrated programming environments, we've been using PyCharm the whole time. Test and debug small programs, sort of based on the test cases idea as well. Trace our algorithm using simple test cases, and a lot of this idea that the code you write should do what it's supposed to do. Sorry, wasn't too loud. That's a big theme because you don't just want software, you want good functional working software that does what it's supposed to do, right? You just throw something out there and it doesn't do exactly what it's supposed to do. For our purposes, nothing really bad happens because we're just basically doing small little puzzles and games and nonsense stuff for class. But when you start writing production software that deals with dollars and people's lives and driving vehicles around and analyzing data and figuring out what are the odds that someone is going to come back and commit another crime after getting out of prison, if you get those algorithms wrong, bad stuff happens to real people. So it does matter. Visio is a great tool. We have it in the lab to draw our diagrams. I usually cheat and just use Word because it's easier, and not everyone has Visio, and there's good online tools, Draw.io as well for stuff like that. Using our debugger. Have we spent enough time using the debugger? I feel like I've shown it a couple times. We never sat down and said, do the debugger, click this, click this, click this. So maybe we'll do that in lab and spend some more time debugging here because that's important. Pre and post conditions as part of documenting our software modules. I'm assuming you guys can write comments, and maybe that's a bad assumption here, and I generally skip over this sort of stuff here. But it's sort of our tests, right? If you can write your tests, then we're in good shape. We understand what's happening here. Recursive procedures, we'll get into that. This is a stretch, and I feel bad about this goal. We're not going to solve a data science problem. We're going to do a really small thing here that's not, it's a bit of a stretch to call it a data science problem because it's our first semester coding. It's okay. So we'll look at how we can model something and test it and try it out. So that's sort of the basis for what we can do with this sort of data science skill set. Is we can take something that's big and complex, we can make a model of it in the computer, and then we can do it a bunch of times and see what happens. The same idea applies, but it's on a very, very small scale here when we get to our final project. And then loops to perform tasks, model process with multiple values. We're working with input here, which is nice. So we're doing pretty good, hitting our goals here for the course. We are officially in week 9. Can't believe that here. So in terms of what's left then, right? We have week 9. We have the midterm week 10, so there's no new content. We have 11, 12, 14, and 15. And plotting and basic graphics are really, really light. I'm going to be honest here. There's so much you can do. We're not going to spend a ton of time doing it, and we're going to be more focused on the final project. So of more content. We've got like 3 more weeks, essentially, after this week coming up of good stuff. Inheritance and recursion, we're going to be pretty light on as well, because if you continue on in the program, that's a major topic in the 2001 course. So this we introduce it, talk about at a high level what these things are here, and then you really dive deep next semester if you continue on. So and exceptions and modules are really quick chapters as well. So we are closing in pretty quick on the end of the content here in week 9, which is cool. Pretty exciting. So reminder, next week I'm not in town at all. So midterm review, I'll post a last year's midterm for you guys to review on 31st, on Halloween. On the Wednesday, 11/2, the midterm will open. It's open book, open notes, open internet, not open neighbor. You guys will all agree to do your own work on this. I promise it's not hard. And then it'll just be due by 11/7 before class starts. We'll have any time that you want to be working on taking it here. It's up to you. You've got it's designed so that if I really wanted people to take it in class, I could have them take it in class. I just think that's wrong, right? I've never had time does matter, right? You don't have unlimited time in the world to work on a project in the industry because you're getting paid, right? And they're not going to keep paying you more time and more time, more time to do something. But it's rarely, hey, sit down, do this thing in an hour, or you fail. That's a very silly way to measure things, in my opinion. So half of it will be quiz questions, and then half will be small coding snippets, smaller than these projects, way smaller than the projects. Like, so I think one will be on. I got to double check here. I'll look at my sample here. But like, write a function to do something. Write something that does something with a string. Write something that does something with lists and dictionaries. So smallish questions, aiming that you could finish it in a class period if you wanted. So that was the goal. So we won't meet at all that week in person. And then we'll come back 11/7 and pick up where we left off. That makes sense for the plan? So we're going to start with project 3 on Wednesday. You've got time to work on it midterm week, our midterm week, because it's pretty light. And then that'll be due on probably the 14th. I'd like that one to be done and out the door. That still gives us enough time, I think, to work on that. So then on the 14th, we can actually get into what the final project is. And that way you've got the whole month to tackle that final project. And with this one, I would strongly encourage you folks to work in pairs. I'm not going to require it, given we're still kind of in the middle of a pandemic. We're getting closer to it being endemic, I think is the right word, but I know very little about this stuff. But pairs are great. I think you'll get a better product out of it. 2 heads are better than 1. You can bounce ideas off each other, think about how you plan things. But pairs have to do work in that collaboration process. So whether or not you pair up or do it individually, you do the same project. So it's still the amount of collaboration is extra time and energy and effort pairs have to do. So you'll do the same thing. And then instead of a final exam in our time slot here, you will hop up in front of the class. It'll be your turn to talk, and you can show off your final project and say, this is what it does. This is the fun things. I might ask you questions about your code, like, hey, what did you do here? That sort of thing. It's 5 minutes usually, no more. I've rarely had it go more than 5 minutes for people. Hop up, show their presentation, and then we're done. So that's a lot of fun. We'll do that on December 14th in our final exam slot, which should be the correct one. The way they schedule these is a little funny, and I've gotten it wrong before, so we will double check that again as we get a little closer here. But they make sure you don't have overlapping finals, which is a pretty good way they do this scheduling. Okay. So hopefully project 2 is going well. That's our Hangman project, right, with very specific functions. I know there are Hangman solutions out there. Right? We're not just taking someone's solution. We're practicing this idea of using functions, building functions, passing values to functions, returning values from functions, right? A very specific way of laying this out here. Takes a little bit of the fun out of it. I apologize, but I want you to be able to like, hey, here's the design. Let's build to this design, sort of thing. And that is generally, wow, I'll have to mark my arm. Generally how things go for more junior members of the team. You're not necessarily doing all of that problem solving and like, hey, here's a big problem, go for it. Depends on your organization, but a lot of times a more senior developer, senior data scientist will be like, here's what I've planned, now you go write the code. to fit this plan, essentially. And that's a great way to learn. It really is, and you can kind of talk to them about their process and that sort of stuff. So I think it fits well with the theme, and we'll go. That should work out pretty well. All right, let's fire up PyCharm. We're going to talk about classes here. So classes is going to be a really big shift in the way that we have approached problems. But it's really cool. Classes are super powerful. Now, technically, you don't need classes to solve problems. You're more than welcome to solve problems. You'll be just as successful solving them without classes. But they're made to make life easier for us as programmers, because classes give us sort of a natural way to relate to code, to understand the code, and to think about our code. So, and like functions gives us some more reusability, which is really nice. This idea that we can have a piece of code and use it lots of different places, right, which is fantastic. So what we do with a class is generally we think of things that can be classes as nouns. And this is why we like them in the real world. So if I say desk, right, you folks can all see a specific desk at the moment, right, that has legs with wheels, it has a certain color height, certain color top here, it's got a certain height, it has attributes of a desk. Now, you might also think of a desk you might have at home, which is probably not this all steel desk that we have here in the classroom, right? It might have a different color, might have a different size, might have a different height. It might not have wheels that roll. It might just have legs, right? These different attributes of the noun. But we all know they're a desk, right? And desks have a common set of attributes, a way that we describe them, but each desk is unique here. So same with like a tree. If I talk about a tree, you are probably picturing some beautiful tree here because it's Michigan fall. I mean, we love this weather here. But they have different attributes. They have different heights. They have different sizes. They have different, is it a breed of tree? Genus of tree? I don't know what you call that. I'm bad at biology sort of stuff, but like oak trees and maple trees and other sorts of things. Then we have pine trees, and there's a different type of tree, but they all have the same set of attributes. So when we write a class, the class generally is going to represent some sort of noun here. So I can say, hey, I want a class for, let's do tree, because I'm thinking about trees. Trees are fun. So we say class tree. So class is our keyword here, and then colon. So everything inside of tabbed in here will belong to this class for tree. Now, there's a special function that we use here called init. So it's init, two I's, there we go. It has double underscores on both sides of it here. Anything with double underscores is a really special thing in Python. It has special meaning. So this define init here is our constructor, initializer. There's all sorts of words for it here. The idea with init is this is how you create an instance of your class. This runs create instance of the class. And what that does is it will go out, Python will go out to the operating system and say, hey, I want to make one of these trees here. And then any sort of attributes that we have here, we get to start listing out. Now, we also use this really cool special word called self. Self, we're going to use everywhere here in classes, refers to the current instance of the class. And that probably doesn't make a lot of sense yet. We'll get to that in just a minute here, okay? But self refers to itself. So when I say self dot, I'm saying, hey, this instance is dot. Now, different attributes of tree, right? We said different things that make trees unique. We said had a height. And then just as a good reminder here, anytime you're using a unit of measure, you should specify what unit you're measuring with. Because when I say height and you say height, you might give me a value in feet, and I might be thinking of a value in meters. And if we are NASA working with our European partners, we will blow shuttles up if we do this wrong, which has happened, because we're still stuck on our terrible system of measurement, which is awful. So height, like in meters, right? Be very specific here. Now we need to give it a value. So for now, I'm just going to say it's 0, because I don't really know what value it should be right now. So but I'm going to give it a value 0 here. It's okay. So the init job is to give values to the attributes. Okay, and then we'll say, I don't know, type maybe? Is type fine? I'm just going to leave it as an empty string because I don't know if it's a maple or an oak or a. There's a lot of kinds of trees, and I just ran out of them here. Type of tree, sure. What other things do we know about trees? What other attributes do trees have? Like if we're describing a tree. I'm sorry? Color? Yeah, so self.color. Sure. Again, I don't know for now, so I'm just going to give it an empty string. So that's probably enough for right now. We can come back and we can add some more attributes later. Okay. So now outside of the class here, I can make instances of trees. So I can say, hey, this is a maple tree equals tree here, and then I give it a set of parentheses. So this here calls the tree init method. We don't have to specify init here because this is one of these like very special meaning functions here. So tree parentheses will run the init method. Then I could say maple tree dot, and as soon as I put in the dot, you'll notice I have access to type, color, and height in meters. It says, oh, which one of these do you want to access? You can set or get, right? We can interact with this attribute. So the type here then should obviously be maple because I'm talking about a maple tree here. And then maple tree dot color. My maple tree currently is orange. It's beautiful right now. I'm really glad to have a big maple tree by my house. Maple tree dot size, or no, height in meters. This thing is tall. It's taller than my house, so it's probably a good 10 meters high, I want to say. Plus, I've never actually measured my maple tree, but somewhere around 10 meters. Or 10 and a half. It doesn't matter too much, right? So this instance of tree is stored in memory somewhere with attributes for height, type, and color. And we can get the values, we can set the values, we can do all sorts of fun things with them. I can make another instance of tree. So the class is essentially a blueprint for what does Python need to store in memory to have this class. So I can make another tree. I have a really nice oak tree as well that we didn't plant, but I found it growing in a bush. So I think a squirrel probably took that acorn and stored it there, stashed it there, and it started growing out of the bush. I was like, it's really cool. And now this is a really tall tree. It's really pretty. So we'll make a tree. Again, calling that init method, and I can say my oak tree dot type is oak, and my oak tree dot color. This is kind of an ugly brown. It's not really have the prettiest leaves here, but that's okay. I won't judge it. And then the size, this one is or height in meters is probably only maybe 5 meters high. It's still a younger oak tree here, but it's growing pretty well. So you might be thinking to yourself, well, we didn't gain a whole lot. And that's true. Like we could have had maple tree type is maple tree color is orange, and maple tree, like used 3 different attributes or 3 different variables for all these things, and use 3 different variables for all these things. Sure, I mean, that's true here. But then what we can do with a class now is we can pass that class around as a single object. So and when we talk about our technical terms here, an object is an instance of a class. So object, an instance of a class. Right? So the maple tree is an object. Its type is tree. So generally, I like to say is an instance of instead of the word object, but I just find that a little bit more confusing. So maple tree is an instance of tree. Right? Oak tree is an instance of tree. We've followed this tree blueprint. We said, okay, these are the things about tree that we know. Then I can start using it places. So if I wanted, I could write my own function like print tree details given a tree. I'm sorry, that's doing the wrong language here. So given a tree, I can say, let's print tree type, and then let's concatenate in here tree.type. Now, when I put tree dot, it does know. Sometimes Python has no idea. Because remember, we can't tell Python that this must be a specific type. I could pass an integer here. And Python will say, oh, sure, it's an integer. I'm going to call it tree. It won't do the right thing, and it will probably crash on us. So we have to hope that people will give us the right type here. essentially is what we're doing, but that's okay. So sometimes you don't get the auto suggest here because it gets confused. I think it knows, sometimes it's good at guessing. So here's the tree type here, and then maybe we'll print a tree color, tree.color, and then we will print a tree height, tree.height in meters, and then we should say, height. Maybe after this, we'll put in meters, right? Somewhere. We want to put this in here. So I can call my function here, print tree details, given my maple tree, and I can print my tree details, given my oak tree. Now this is a little bit nicer than having to call a function and give it a type argument, a color argument, and a height argument, right? I don't have to give it 3 different arguments. I can give it one argument. Here's the instance of tree. So we're taking this idea of a noun and we're doing this thing called encapsulation. We're taking all the details and encapsulating them into one nice, neat little package. Okay, that's what classes let us do. So classes let us do this encapsulation process. So we've encapsulated the idea of a tree into a nice, neat little class. Just as a way to think about it here. So with this process of, here's a noun, I'm going to take all the details about the noun and put it into a nice little package here, a nice little class here. Bob Ross would be proud. We can't convert float, can only concatenate string to string, right? When I have a height in meters, can't do this concatenation. Well, that's fine. We'll just say, hey, please treat it as a string, right? No worries here. Convert it to a string, please, Python, so you can print it out. Cool, and now we see, here's my maple tree, it's orange, height. Here's my oak tree, it's brown at this height, this sort of thing. So I've got some tree details, okay? So we have some small gains here currently. The next thing that we can do with classes is we can restrict access to attributes and make them go through public functions. And this isn't going to make a lot of sense, but that's okay. So the idea that I can just set a height in meters is a little bit wrong here, because I could say like, hey, it is -5 meters high, because I can give it any value I want. And we know, like in the real world, a tree can't have a negative height. That just doesn't make sense in the real world here. So allowing someone to do this to your tree is really a bad thing. So one of the ideas here with encapsulation here is encapsulation allows us to, protect our attributes. And the idea of protecting your attributes is saying, I know what a valid range is for this attribute. I'm going to make sure you don't give me something invalid. So if they just have access to height in meters here, there's nothing we can do about it, because they can just go set this value. So what we can do, and Python's a little bit funny here in that it's still trusty. Python will assume people will do the right thing here. I can put an underscore in front of height in meters. So using an underscore, start a variable, indicates it is private. This idea of this idea of private means it shouldn't be accessed directly. So now when I come back to my tree here and I say maple tree dot, oh shoot, hang on, I gotta take that line out. Maple tree dot. Notice there is no longer a value showing for height in meters. I get type and I get color because I've not indicated that these are private. If you don't add that underscore, what we're doing is we're saying, oh sure, have access to the value. Go use it, it's public. Other languages are actually strongly controlled around this, and you physically can't change the value. I guess physically is the wrong word because I'm not putting in zeros and ones, but you can't access that value. Now, if I want to, Python will let me say, here's my height in meters equals -5. You can access it here, but you shouldn't. Values, you should not. So Python doesn't have a strict control around this. In another language like a C++, if I mark it as private, you can't access it. There's physically You're just not allowed to. You can't go get this value. So this is just a convention that we follow to mark things as private. There's no hard and fast rule, right? So shouldn't is really, that's all it is. It's saying, please don't do this. Okay. So again, I'm not going to go do that here, but you could. So what you do then is you make, when you start this encapsulation process, is you have private attributes with public functions. Hey, happy Tuesday, Wi-Fi Paladin. Thanks for hopping in. Blur's Day, yeah. It's Monday. I don't know what day it is anymore. So the idea with public functions is we're going to define a function here, like set height in meters. Given self, so we always need self when we write these functions here. And then if you want to set the height, you need to tell me what the height is. So you're going to tell me the height in meters. And what I can do then is I can take my self dot height in meters attribute and set it to the height in meters you give me, if it makes sense. So I can do some sanity checking. I can say, hey, if my height in meters is greater than 0, let's take the value. If it's not, then maybe I just assume I'm a 0 height tree, because sure, you haven't told me a height yet. So this is a public set method to do sanity checking, bounds checking, control, bounds checking for attributes. So I know anything greater than 0 we'll assume is valid. Now, I probably don't have a 1,000-meter height tree, so we could have an upper bound, we could have a lower bound, we could have, anything you want to do in code we can do here. For now, let's just assume greater than 0 is okay, right? Because I don't actually know what the max height of a tree is. I'm sure we could look that up somewhere. And it's probably different for each species of tree, I'm assuming. Okay. Obviously, you guys aren't botanists, or is that arborists? Right? That's tree folk. Arborists. I think that's the right word. That's okay. Right. We're just using this as an example here. So if I have a private attribute here, people can't go get access to that value. So in my little function here, I can't go get this height in meters. It doesn't exist anymore. So I also need to give them a way to get the value out. So we generally have these get and set methods. Getters and setters. Some people call them accessors and mutators for accessing the value and mutating or changing the value. People love coming up with all sorts of fun words. I prefer set and get because they're easy. So you can set the value and you can get the value. So we need then another method here for get height in centimeters, or meters here. Now, you don't need to give me any arguments here to get the height out. With just this special self thing, so I'm just going to return my self dot height in meters. So in my function here then, I can call tree dot get height in meters to get the height in meters here. I can't just go use the attribute directly, or I shouldn't go use the attribute directly, but this is a public function I can call that runs on this instance of tree. So whatever variable name you're using, that's the instance you're working on. That's the object we're working on. So in here, if I want to go set the color, it's maple tree dot set height in meters, and we'll say, hey, this is a 10-meter tree. So what happens inside the code here is self becomes this instance that we're calling the function on. It's kind of this magic thing in Python. So maple tree is this current instance we've created in memory. When this code runs, when we run the set height code, self is the maple tree, right? Because I have one maple tree in memory over here, and I've got my oak tree in memory over here. They're different objects. They're different instances of tree. It's the exact same function, right? The exact same code runs, but what's different is what value self is. So same idea, I would set height in meters here. Then, so if I tried to set height to -5, it won't work. Right? It won't take a -5 because we wrote the code that says if you give me a negative value, don't take it. Right? This set height in meters code will run and say, oh, you're not greater than 0, your height stays at 0. So if we run this in debug mode, right, I'm going to put a breakpoint in. So next to the line numbers, you put a big red dot in here. That's a breakpoint. Don't hit the run button, hit the bug button for debugging. The funny story, there actually was years and years. I think Zybooks had this, right? In the first chapter, there's an actual bug on a note card because that's how you used to program things with note cards and holes in them, which blows my mind. My dad still has a stack of note cards, and he won't throw them out. I mean, he can't do anything with them anymore. There is no place to take them to read his program. Like, he's holding on to this thing because he wrote a program on note cards, and it's kind of cool. All right, so debug mode, it will pause when it gets here. So we can see I have a maple tree. It's a type of tree. It's at this memory address. And we don't care too much about these memory addresses, but that's where it is, right? Here's the oak tree. It's at this memory address. They're different locations in memory. They're both trees. They're types of trees, but their attributes are unique. So I can have a bunch of different trees loaded in memory, each with its own set of attributes. We've followed this class blueprint, this idea of a tree here, this noun, and now we can represent it in code. So maple tree, it has a color of orange, it has a type of maple, and notice it has this little section called protected attributes. We can go open that and look at it here, and we can see, hey, the height in meters is currently 10. Sure, but we don't have direct access to it. It is protected here. We could if we wanted to, but we shouldn't. Right? Python will just do the right thing in Python, and life will be good for us here. That's essentially like those stickers on the back of things. Like, if you remove this sticker, you voided the warranty. If you start accessing private protected attributes of classes, you voided the warranty. The class probably won't do the right thing anymore, right? Okay, so if I want to step into my code here, so that's the down arrow with the little lines here, step into, we'll go into the function here. So now I'm set height in meters, and I have a self. Self is the brown oak tree, right? Because I said oak tree dot. So whatever was on the left of the dot is the self when the method runs. That way we can keep these things different, and Python knows which one we're interacting with here. Now it's going to try it. Okay, hey, is the height in meters, is -5 greater than 0? Well, no, it's not. So height goes to 0. Okay, nothing happened. And we can print our tree details, so we could step into this one if we wanted. Right, tree details. So we'll see this instance of tree now. The thing, my variable name for tree, happens to be the orange maple tree. The next time I call it, it'll be the brown oak tree. Right? So we can pass a variable that represents a tree, a type of tree, lots of different places. And we could step into the get height in meters if we wanted. Now, self, again, is that orange maple tree. It's going to return this value of height in meters. So if we're using this idea of having protected attributes, because I want to make sure that people don't give me bad values, we need the public get methods, probably some public set methods or ways to interact with it. Okay, so we'll just continue on and it will run to the end. Here we can see it's 0. So now, sets and gets are great, but that's not the only thing we can do with trees, right? So generally, when we start thinking about methods or functions here, we think these are generally the verbs. What happens with this noun? What does this noun do? So you might have a function like grow. So when a tree grows, what happens? Well, its height changes. I mean, width changes and roots. I mean, but of our attributes, we just have the height changes. So I'm sure there's some formula somewhere. I'm just going to come up with some nonsense here, and it doesn't have to make sense. It's just an example here. We're going to take our self height in meters, and let's multiply it by 1.1. I don't know. We'll grow 10%, right? We're just coming up with something here. 10% height growth, which is not how it actually works, and I'm sure it slows down as it gets older and all sorts of other stuff, but that's okay. We want to have something we can interact with here. So now I can take my tree, I can print my details, and I can say, hey, grow. I can call the grow function of my maple tree, and this attribute will change. Right? And I can print my tree details, and it should be taller. So it went from 10 meters to 11.0 meters. Right? It grew. So whatever problem we're solving, if there's a noun in that problem, it could be a class. Doesn't have to be, but it could be. So as we look at how we want to approach problems and solve problems here, classes give us this ability to encapsulate all of our details together, protect our attributes to make sure we don't get bad values, which is really nice and important here, especially when we think about classes as being reusable code, right? As you get into bigger and bigger and bigger projects, there's code out there that you don't have to write. I mean, there's a whole Python library. We don't have to figure out how to generate a random number. We don't have to figure out how to get an input here. People have written that stuff for us. And as we start doing interesting things in data science, there are libraries full of code that help us solve those problems. All sorts of math functions. When we get into plotting and graphing, all sorts of graphical functions here. Code that's already been written. So classes allow code to be reusable in a nice way, a little more than just functions, right? Because classes then can interact with their attributes. Right? When we just have a function like math random, it's just a random number. There's no, it doesn't have to rely on a previous number or whatever has to happen here. We don't keep track of any of these things. But a tree here, right? Our grow method relies on what its existing value was. So if we need to have a bunch of values and they're related here, they depend on each other with how they interact here, class puts them in a nice little package. It's another idea of abstraction. So abstraction is another technical term, another fundamental of object-oriented programming is we don't need to know the details. Right? You get to work with things in an abstract manner, meaning we don't know how it does what it's supposed to do. Like when we ask for a random number, we don't need to know how it generates a random number. We just know it does what it advertised. The method's called random integer. It gives me a random integer. That's it. It does this. So my method here is called grow. I don't know if it actually has a cool formula with some sort of logarithmic curve so it grows faster when it's younger and slows down as it gets older. I don't know, right? You can come up with any sort of cool way of actually making this simulate real growth here. But we just know it grows. So I can say, oh, hey, let's have a little model here. How many trees are in your yard? What year is it? Let's imagine now 10 years from now, let's grow our trees 10 times, and I'll tell you how tall your trees are in 10 years. Sure, we could draw, make some nice little modeling software for a landscaping company and say, hey, you can show your customer, here's your now picture, and in 10 years, here's the then picture. You're like, hey, look how pretty it is in 10 years when your trees are big. It's okay to buy small trees now. Sure. I'm kind of stretching this tree example as far as I can get it. It's getting a little thin here, okay? So abstraction is we just use the public methods or functions. So when we're writing a class here, people don't need to know all the details to interact with the class. Same thing applies, right? They don't need to know what our growth curve is and how we define a growth curve. They don't need to know the implementation details. They just need to know, hey, I tell it to grow, then it grows. And maybe we have something smart in here, like a willow tree grows a certain rate and an oak tree grows a certain rate, and we got lots of choices. Hector, my friend, thanks for donating to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. I've had a lot of coffee. I'm feeling good today. This is good. Okay, so we can grow. So this idea of classes, of encapsulating all the details together, making a nice little package, taking all their attributes, putting them here. Generally, we want private attributes with public functions. That's a good rule of thumb, right? Because you don't want people changing values that they shouldn't be changing. So using public functions like a set height allows us to control that. Okay, let's do another example here because this is fun. Is that okay? So let's look at a different class here. Let's write a class. How about for, should we do electric vehicle? Here, vehicle. So an electric vehicle then, we're going to define this special init method. Excuse me. It has a couple attributes, right? Cars generally have a make, right? Who made the car? What company? They generally have a model. What's the model of this car here? And they will also, for an electric vehicle, have a max capacity for the battery, right? So and now again, I want this to be a private value because I want to make sure we're getting good values here. Like this needs to make sense what the max capacity is. It has to be within a certain range here. For make and model, I mean, anyone can make their own car company and call the car anything they want. Just look at what Elon did with Tesla, right? And he has funny car names. I guess they're only funny if you put them all together, right? And you look at the order in which he made them. Anyway, so we'll have a max kilowatt hours, or I don't know what, battery max kilowatt hours capacity, something like that. Again, we'll start it at 0 until we know otherwise, but we'll say, hey, here's what the max capacity is for a battery. Now, the other thing that cars probably know about itself is the current kilowatt hours, right? Like how much is it actually charged here? And then another fun thing, cars like probably have an odometer, right? Odometer, like that tells you how many kilometers you've driven. I'm going to say in kilometers here because we're going to specify our units here, right? We'll start that off at 0. So every brand new car has been driven no miles, has no max capacity, and has no charge in the battery. We'll go fix those in a minute here, right? Now, in the real world, the max capacity degrades. We're going to pretend like it doesn't because it's more trouble than it's worth here. So if we want a value to be set once and never changed here, we don't need to have a public set method here. So I could have a public set battery max kilowatt hour function here if I wanted, but then you can go change it, which I guess might make sense, but I don't think people are actually going out and buying new batteries for their cars. I feel like that's not happening yet. That was a dream at one point, but it doesn't happen in real life. So what we can do is, this is just a function. This init method is special, it's a function, but it can take arguments. So if we want, we can say, hey, by the way, give me some arguments here. We just comma separate, just like any other function we write. You can accept arguments. So I can say, hey, tell me the make, tell me the model, tell me the battery max kilowatt hours capacity, right? And I can say, hey, set my make to the make, set my model to the model, set my max capacity to the max capacity. Now, this is where it gets really important. This is the self.make, so that's the instances make here. This make is the argument. Some people aren't fond of this. I think it's fantastic. So I have two variables with the same name. If you're not careful, you do the wrong thing. If you say make equals make, now I'm setting the argument to itself. I haven't done anything here. Nothing's changed. Make equals make, because I haven't set the instance attribute, right? So self.make is the instance of electric vehicles make value. This make is the argument you gave me. So this idea, the technical term is we've shadowed the variable. We have two variables with the same name. So we have to specify self-make versus make. Just be a little careful here. It can cause some confusion, but it's really nice to give good variable names in your init method, because later on, if you want to go use it here, I say, hey, I want my Bolt is an electric vehicle, and I start some parentheses here. I should get, here we go. I get it's telling me right here, this little IntelliSense is saying, hey, give me a variable for make, give me a variable for model, give me a variable for battery max kilowatt hour capacity. So if you don't name these well, like if you just say, hey, this is MA, this is MO here, that's perfectly fine. Like the code doesn't care, but people care. So when I go make my electric vehicle, where did it go? Bolt equals electric vehicle. Come on. Give me the suggestions. All right, it's not suggesting it for me now. It's being unhappy. There it is. You get mo, and it's not as helpful, right? We want the code to be helpful. So just use the right things here for make and model. Come on. Undo, undo, undo. Okay, so that you have good names here. It's pretty easy. Now, again, we haven't done any sanity checking, which is probably a bad thing here. We're going to punt on that, right? We'll just say we should sanity check the capacity. We'll do that later. Okay, we'll come back to it, right? This is a to-do for us. Okay. My battery starts at 0, my odometer starts at 0. So you can make a Chevy Bolt with a capacity of, I don't know, 13 kilowatt hours. Go for it. If you have a private value, we need a way to get that value. So we need a public get method at least. A get battery max kilowatt hours capacity, right? That can return my self.battery max, right? Give them a way to get the current value out, but not a way to set it. So what that means here, right? If you don't have a set method, so if you accept an argument in the constructor or the init here, and don't have a set, it's pretty much read-only. This idea, you set the value once, and now we're never changing it again. It's a read-only value, which kind of makes sense, right? Like once you have a Chevy Bolt, it's probably never not a Chevy Bolt, right? So in terms of what makes sense for our class here, as we're modeling a real object, once you tell me what the make and model is, I'm keeping it. You can't change the make and model, right? Which for our class makes sense. For other classes, it's fine. Maybe it makes sense to change. That's okay. Like if we had an attribute for color, you can change the color of your car, right? It's not cheap, but you can go paint your car if you like different colors, right? So some attributes make sense to change and some attributes don't make sense to change. It just depends on what problem we're solving, what we're trying to do here with this. So we've got get methods here, then we'll define a get. So again, with this make and model, I'm going to make these private as well. Put underscores everywhere because I don't want them changing. So a get make returns the self.make and a get model. Now, this is kind of tedious, right? Having to write all these methods that just get things and return things. Hopefully you're thinking, yeah, this is really tedious. Yeah, it is. So you can go to generate. Oh, where is it here? Is it implement? No. Where'd it go? It's not writing it for. There's a way to make it write code for you. I will find it in a little bit here to do these here. So I can do a get model, return self model, and then a get current capacity, right? So define a get battery current kilowatt hours, sure, return self dot battery current kilowatt hours, and then define get odometer in kilometers self dot odometer. Right? So all of our attributes here are private. We're saying don't go touch them. You can't have direct access. You have to use my public methods. So right now we only have gets. We don't have any ways of interacting with our vehicle, right? Well, what makes sense to interact with a vehicle? What ways do we interact with an electric vehicle? How do we interact with this current battery charge? Well, we charge it. We plug it in, right? So we can write a method here like charge, given a kilowatt hours to charge, right? So, hey, I'm going to go plug my car in and say, hey, car, will you go charge for 10 kilowatt hours, please? Or some amount here. It's not exactly like a gas pump. Usually you just leave it plugged in and stop when it's full. But we'll just pretend, right? I told it, hey, go charge this amount, right? Because the timing and the amount of charge per hour gets really confusing. And if we had to say, how many hours we're charging for, that's a lot more arithmetic. Okay, we're just going to pretend like that's all happening here. So we'll pretend we did the arithmetic for hours to kilowatt hours. Hours charging kilowatt hours. Is that okay? All right. Okay. So we'll go add that to our battery capacity, but we want to do some sanity checking because I want to make sure I don't get to an invalid state. And people do the weirdest things with our program. So if I'm writing this class for electric vehicle and someone else is going to use it, right? Because I'm writing some really cool code and everyone's going to want to use my really cool code here. I need to make sure it doesn't break if they do things they're not supposed to do. So I can check, hey, if my kilowatt hours to charge is greater than 0, let's go charge. If you give me a negative value, I mean, I guess GM just came out with this whole thing where they're actually going to do this and like pull it out so you can power your house, which is a really cool idea, but more complicated than we need. Like the real world is really complicated. We're just trying to do a basic version here to get the idea down. So maybe I picked a bad concept here, but you can't charge it a negative amount. You can use the battery if you want to take the charge out, right? But my charge method here, my charge function tells me how much juice do you want to put in. So if it's positive, right, then we'll take my self.current kilowatt hours and add the kilowatt hours to charge, right? Life is good. Go add it to the battery. Oh, but what could happen now? If they said, hey, I want to charge 10,000 kilowatt hours and my battery only holds 13, my class is in a bad state, right? I've let a bad thing happen. So we need to do additional checking, right? We can say, hey, by the way, if my self.current battery current kilowatt hours is greater than the self.max kilowatt hours, let's just pretend like that didn't happen, right? We'll just change it. If a bad thing happened, Oops, we'll just pretend it didn't and say, oh, by the way, if you went over, pretend like you stopped, right? Put yourself back in a good state. By the time this charge function is done, no matter if you told me 13 or 10,000, I'm still going to stop at my max. If you went over the max, right? If you only wanted to charge 1 kilowatt hour and my max was 13, that's fine. I'll just be plus 1. It's okay. So I'm protecting the integrity of my object here. Right? Making sure you don't give me negative values and making sure you can't put more juice in the battery than it can physically have. So it makes sure that my class, my object, is in a good state all the time. That's why we like our public functions here, because we have control over what happens to our attributes to make sure that the right thing happens. So then other things we might do with a vehicle, you might drive your vehicle, right? And if we're going to drive it, we're probably going to tell it how many kilometers to drive, right? Say, hey, let's go drive 5 kilometers, right? So if we're going to drive, well, now we need to know how many kilometers we get per kilowatt hour. So we probably need another attribute in here. I think we missed one here. So let's add a self dot kilometers per kilowatt hour. And I don't actually know what that value is, so maybe you tell me, right? Now, I know this is not a fixed value here, right? No, it doesn't work like this in real life. But that's okay, right? Don't worry too much about it. This value changes, right, depending on what else the car is doing and how fast you're driving it and how aggressive you're driving, all sorts of things here. We just want a very simple, we're going to imagine life is good, and it always gets the EPA whatever number here. Can we just pretend? Okay. All right. So then we probably need a get method for that too, right? So we can find a get kilometers per kilowatt hour, return myself dot kilometers per kilowatt hour, right? If I have a private attribute, if I don't have a public function, once they give me the value, it's gone forever. So generally, most of our attributes will always have a get method because they want to be able to see what that value is later on down the road, right? If we make a bunch of vehicles and I don't remember which one's which, and we want to know what those values are. All right, so when we go and drive here, we can calculate then, given a kilometers to drive, how many kilowatt hours it takes. So it's kilowatt hours required is my kilometers to drive divided by my self dot, self dot kilometers per kilowatt hour. Right? Take kilometers divided by kilometers, you're left with kilowatt hours. You did this back in chemistry class, right? This had a fancy term for it. I forget what it was. Right? But if I want to drive 10 kilometers and I get 5 kilometers per kilowatt hour, 10 divided by 5 will tell me 2. I need 2 kilowatt hours required. Right? It's just arithmetic. Okay? Once I know what that is, now I can take that charge out of my battery. Sure, why not? So we'll take our battery, or maybe we even want to check, do we have enough? Right? We say, hey, if the kilowatt hours required is less than or equal to my self.current kilowatt hours, this is good. I can go do this thing. Right? Do we have enough battery charge? Drive that far. Right? If we do, all right, let's go pretend we drove. Sure, we'll take our self battery, kilowatt hours, we'll subtract the kilowatt hours required, we'll take our self.odometer in kilometers and add the kilometers we've driven here. Right? So you sit in your car, you say, hey, GPS, I want to go to this destination. And it says, uh-oh, we've got a problem. You don't have enough charge to get there. Bad news bears, right? And that's a whole other issue with range anxiety and all sorts of other problems with electric vehicles that we're not getting into right now. The real world is messy, folks. Like if that's the only thing you take away from this, that's fine. The real world is messy. Okay? And it's hard to model in code all of that messiness. But it's doable. Like we could probably model all of that in code. And I'm sure the fine folks at GM and Tesla have modeled all of this stuff. And they actually have code for all of this. I'm positive of that. Right? It's doable. We're going to take a very simplified version of it here because this is our first class. Is that okay? Cool. So if we drove, fantastic. Now, when someone calls drive, how do they know if it worked or not? Right? Functions can do stuff or they can do stuff and return value. So why don't we just say, let's return true? Yeah, it worked, right? We had enough battery, we went and drove, we got a true back. If we didn't have enough battery, I can just return false. Hey, you didn't drive, didn't work, right? Didn't happen. So I can make vehicles then, and I can try and drive them. And I can say, hey, if this drive method was successful, I went and drove. If it wasn't successful, I didn't drive, right? And if you wanted, we could have the user do something. So you might have noticed in my class code here, none of this ever uses input. That's another idea with classes, right? We want them to be reusable. When was the last time you used a program that popped up a little black box you had to type into for console input? It's probably been quite a while, or ever, never for you folks, right? I'm old enough, I remember it. But that's okay. It's another story. So if my class relies on using input that the user types in at the console, I can't use it other places. I can't use it in the web application. I can't use it in some, I don't know, onboard computer application in the actual computer hardware or vehicle hardware. So you want classes to be separate from user input. What that means is you just take a bunch of arguments. So if you need values, you take that value as an argument. What I see a lot of first semester students do is when I say, hey, your method needs a value, the first thing they do in their method is they say, hey, I get a, hours is going to be an int of an input or a float of an input, enter some value, right? You don't want to do that, right? Because that's what the argument is for. The class says, you tell me what the value is before you even run the code. If your code is going to ask the user to type stuff into the console, that's up to you. That's fine. You can still use my class. If your code gets the value from the web somewhere, someone goes out to a website and plugs some values into a website, and you use my class, that's great. If your code gets a value from the user's phone somehow, and then uses my class, that's great. We want to separate input from the logic of the class here. That's another thing we're doing. That's why classes are very reusable here, because they don't tie themselves to a particular type of input. Here, so like this is don't use input in classes, right? Use the arguments. Does that make sense? So you just accept the argument. If you need a value, this is how the function is defined. You can't call the function unless you give me a value for kilowatt hours to charge. Okay, same with drive. So let's make a vehicle. So if I wanted, I could ask for input down here in the rest of the code, separate from the class, because that's all we have so far. When we get to the very last week and we look at graphical user interfaces, we can have the user like click buttons and do things and type into an actual like screen with buttons and text boxes. And it looks like an actual modern application that people use. It's not a regular input, right, at the console, which is fantastic. So we can use this class again later if we wanted to. So why don't we just make a vehicle? Should we make a Bolt? Then is an electric vehicle. Now, I don't just give it the parentheses here because this init method needs arguments. It needs a make, it needs a model, it needs a battery max capacity in kilowatt hours, it needs the kilometers per kilowatt hour. It needs all these values here. So sure, that's fine. It's a Chevy, it's a Bolt. The battery max capacity, it's something around 13. I don't actually remember what it was here before. And I think I got probably like 7 kilometers per kilowatt hour. I forget exactly what it was. Maybe it was a little less. I used to have one. And then the pandemic happened and I stopped driving places. And I realized it was kind of silly to pay insurance for 2 vehicles when we only needed 1 vehicle. So we got rid of it, which is cool. That's fun. So now I drive the big giant van around, my 12-passenger van. But it's okay. Cool. So now I have a Bolt. So then I can now charge my Bolt if I want. Let's go charge it. How many kilowatt hours should we charge it? Well, I know I can go up to 13, but if I give it like 500, it will stop at 13. Right? I just leave it plugged in all night and it charges. Again, we hand wave some of that charging per hour nonsense. We'll just say, hey, fill it up. Give it a big value. That's fine. And I can drive. How far do we want to drive? Well, if it gets 7 kilometers per kilowatt hour and it has 13 kilowatt hours worth of charge total, 7 times 13 is some big number. I forget what it is here. 70 plus 21, is that 91? I should be able to go about 91 kilometers here. It should be perfectly fine. So, okay, so my numbers are off. That's okay. It's not the real world. We're just pretending here. That's fine. So I can say, hey, if my bolt.drive, 91 is true, maybe I'll print you had a nice drive, right? Else, print you can't go that far. Try again. And maybe this might be a user input then, right? Maybe I'll ask them. I don't know. Or we can say, hey, how many kilometers do you want to drive? And we'll go and try it. And it doesn't have to be a hard-coded value here. Let's ask them. So we'll have a kilometers to drive. Here's an int of an input of how many kilometers do you want to drive? Right? And we'll just use that value here. So if the user gives me a big value and I can't drive that far, I'll find out. If they give me a small value and I can drive that far, great, we did it. And then we can do some sort of loop or anything we wanted that we can do with our code already, right? Let's give it a run. Oh, missing required positional argument. Make, model, battery, kilometers. Make, model, battery, kilometers. Oh, where did I? Oh, right here. Sorry. This is that line. I typed it in before and forgot where I typed it. So this was not valid here. You can't call an init method with no arguments if it requires arguments, just like other functions. No good here. Let's try it again. All right, how many kilometers do we want to drive? How far should we go, folks? 91. You had a nice drive. Cool. Should we try it again? How far should we drive? More than 91? How about 92? You can't go that far. Try again. So it seems like it's working, right? I know based on these values what should happen. Or is this true or false, right? So right now we're testing our code because I know what it's supposed to do. I did the arithmetic essentially, and we're checking, did it give me what I wanted, right? So any code that's worth writing is worth testing. I'm a real strong believer in that. Now, the idea of testing your code can be a little funny here. And generally as a developer, people pay you to write code. Sort of your job as a developer, right? Generally, they want the code that you write to be correct. That's a pretty good assumption, right? So I would always argue when you write code, it's worth testing it because you want to make sure you did the right thing, right? Just like writing an English paper, you get typos sometimes because you know what you meant, but what you meant didn't always come out in words or didn't come out in code. Same thing happens to developers. So, hey, thanks for joining online. So it's important to test it. Now we're running a little short on time today. So on Wednesday, I think I'll show you how we can make the computer do this, which is much better. Like when the computer does spell check, it's much better than when we do spell check, right? Because the computer is better at this sort of stuff here. Same idea goes with our code. We can make the computer check these things for us. Now, it still takes work, right? And it's not automated. There's no like verify my code button, as much as we wish there was here, right? It's still some work here, but we can make the computer say, given these inputs, this is what the output should be. That's what we've just done here, right? I said, given some input here, I know what the output should be. We can do that and make Python check it for us. Say, here's the inputs, here's what the output should be. And if it's not the right output, then stuff happens, I will notice, right? And we'll look at what all that looks like in a little bit. But that's the idea. So we can write our classes then to let us interact with values in certain ways. So there is no set odometer method. There is no set charge battery current kilowatt hour method, right? If it doesn't make sense for the problem we're solving, you don't have to have it. That's the wonderful thing about writing classes, right? Whatever makes sense for the problem we're solving is what we get to put into code, right? And then we're protecting our class. We're protecting the integrity of our class to make sure you don't do dumb things. Because we're all great, and when we use our code, we would never do the wrong thing ever. It's other people, other users are going to give us weird values here. There's a really funny shirt I got to look up. I want to buy this shirt, but I haven't yet. It's a QA engineer bar shirt. Yeah, here's. I think it's this one. Can I make that larger? They order a beer. They order percent beers. They order 99999.99 beers. They order negative number of beers. They order null beers. They order some weird character beers. Other nonsense. Like this idea that you're going to get weird stuff from people. So there's a whole specialty in software engineering around quality assurance, or QA, making sure that code does what it's supposed to do. And not only does it do what it's supposed to do, but it doesn't do what it's not supposed to do. That's equally as important, right? Because just because it does what it's supposed to do when you give it good inputs doesn't mean it won't break when you give it bad inputs. And we get the weirdest things from users. So this idea of having protective or defensive code, making sure we don't break, we don't get into an invalid state, is super important, because the real world is messy, and messy stuff happens to our code, and things that we don't always expect can be given to us, and we have to check to make sure we maintain the integrity of our class here. So if we never checked to make sure you can't overcharge the battery here, and I just said, okay, when I go drive, let's base it based on your current kilowatt hours. If current kilowatt hours was 10,000, I just told you you can drive further than you can drive, and your car is going to stop in the middle of the road somewhere, and you're going to be really upset with your car's navigation system, right? Bad things will happen. So protecting the integrity of our class, making sure our attributes are valid and within whatever range we know is valid, is important. Okay, so that's sort of the basics for classes here. So it can be super simple like a tree. You got some gets, you got some sets, maybe you have a grow method, right? You don't have to have all the fancy stuff here. The other thing it lets you do, and what we're going to do in lab, is we're going to go back to our store project again, because you guys aren't sick of it enough yet, I'm sure, is we can write a class for an item in a store. That class can have an attribute for the price and an attribute for the quantity, right? So I'm going to just encapsulate all those details together. Here's what an item at the store is. It has a name, it has a price, and it has a quantity, right? And I can use that item class then to store all those values. So I don't need to have, here's a list associated with a string here, and I know the first value in the list happens to be the price. As you can imagine, it's easy to make mistakes with that, right? If I don't get the right value or accidentally get the quantity instead of the price, I've either charged you way too much or way too little, right? And that's going to hurt someone's pocket somewhere. So if we can use a class, we can verify it does the right thing. And then same with like checking your quantity. When you go change the quantity, if you can't have a negative amount of items in your store, that's not physically possible. In your code that you wrote for your store example, we were supposed to check for that. But if we had a typo somewhere, now all of a sudden our store thinks we have negative 10 toothbrushes. I don't know, whatever it happened to be, right? So we can add in additional checks to make sure that we never get negative values of items, right? Our store makes sure that doesn't happen. If you run an online store and you sell things you don't have to customers, what happens to your customers? Yeah, they're going to report you for scamming them. Like, hey, I paid you money, you didn't have the item, you sold it to me anyway. There's a whole other reasons for accounting and stuff that we get into that, but the same idea. So making sure that our classes maintain a valid state is super important here for real things, real world things. So, and again, the real world is messy. We'll get to that later. So, all right, I think we're pretty good. So why don't we take a break and we'll head over to lab and we'll write a basic class for the store item here, and we'll go from there, okay? All right, awesome. Thanks, folks. I'll see you in a little bit. Does anyone want a coffee? I'm about out. I'm going to try and make it to the coffee shop before lab instead of during lab. You guys don't drink coffee? You're missing out. You're missing out. So depending on which medical study you read, coffee is really good for you. And the important thing is you just read the ones that agree with you, because that's how science works.